Hi, everyone. I'm Jess, and I'm the content manager here at Course Report. Course Report is the resource for helping people find the right coding boot camps for them. At Course Report, you can research the best coding and digital skills boot camps from all over the world, find out which technical skills and languages to learn, where to apply, and how to fund your own boot camp experience. Today, I'm happy to have Will Sentence, the CEO of Codesmith, joining us to talk about how software engineers are embracing AI. So thanks so much for taking the time with me today, Will. Let's address some of these doomsday headlines that I'm sure everyone has been seeing. Do you think AI is here to replace software engineers?
Fab question. So there is a overused phrase, AI is eating the world, but flipping heck, when you're able to have your software deal with the kinds of problems that previously you couldn't, things that involve uncertainty or nuance, I'm talking things like legal advice or healthcare, healthcare recommendations. These are the kind of problems that now with AI, particularly LLMs, large language models, and we'll talk more about them, software is going to be able to solve. The people who build those are software engineers. They too will have more tools. We're talking things like GitHub Copilot, but they also still will have to understand at the very core how the things are being built. So it is not a technical product manager even, it's got to be someone who understands under the hood, maybe that's a technical product manager, but it's not a product manager, and it's someone who understands under the hood what's going on in the technology they're building. And to me, this is why it's all the more important that you have people becoming, let's call them technologists or software engineers, who lived the experience of being the user. We have a grad, they were a nurse for 9 years, and now they work at a medical staffing agency as a software engineer. I think that's bloody brilliant. That's somebody who's lived it, now leading it. And when you're expanding the realm of things that can be solved with software, because now you can deal with questions like written advice for a lawyer, which you can never do before. The tools were not there with models, with generative AI models, you bet you can. And it's exciting, but also, as I say, every bloody thing's going to be solved through the software layer. We've got grads at John Deere, the company that makes beautiful tractors that my nephew loves, but is increasingly thinking of itself as an agricultural software company. New York Times proudly hires more software engineers than it hires journalists. Oh, actually, I should say that John Deere has more software engineers than it has mechanical engineers. Many of our societal problems are going to be solved through the software layer. Fascinating, exciting, but as I say, all the more important then that the people building those, because it's going to be those software engineers, represent society at large. And that's why I respect all these coding schools, because ultimately they do allow a path for people, whatever stage they're in, to enter into this position of autonomy over tech, not being on the receiving end of tech.
Yeah, and as you mentioned, coding boot camps, I feel like we're seeing some kind of skepticism coming up with the rise of AI. So what would you say to a headline that says coding boot camps aren't really relevant anymore in this time where AI is such a thing in the job market?
I mean, they have to evolve for sure, no doubt about that. We've got someone who's in the final stages of the admissions process at the moment, and she's a data scientist from Meta, who increasingly realizes that at the core of everything is bloody software engineering. If you're a data scientist, your job is to build the model. So the model is a collection of weights. Very obscure immediately. It's the thing that allows you, it's the code, the steps taken with your previous data to allow you to make predictions about new situations. So your model might look at previous users' purchase history. What have they bought? Previous users' searches. There's a good example. Previous users' searches. What have they searched for? And according to that, then make predictions about what the next user might search for or the next user might purchase. The data scientist does that building of the model using the prior data, often in a very small scale way. It certainly ain't productized live on the internet. And yet that's what makes it so powerful, is to turn it into something that users and businesses and others can use. That depends on software engineering. And so even, our candidates coming from data science backgrounds, building ML models, building AI models, essentially AI scientists, come to Codesmith, or let's just be more generic, a coding bootcamp, because it ain't just Codesmith, in order to become someone who can make predictions, who can build predictive models, but have them be a product. That means something that someone can use on a computer. That is software engineering plus. So if you think about a coding bootcamp as primarily around that, building product, great. Another way of looking at it is, okay, what if I want to be an ML engineer? While we've had some Codesmith grads already take on ML engineer jobs, we have a grad who went to TikTok as an ML engineer, but he did a lot of self-study in ML modeling. Codesmith does not make you per se an ML engineer unless you come with a heavy data science background already. So can a coding bootcamp work for a pure ML engineer all in one program? If you want to be an ML engineer, you've got to be good at analytic. Analytic means the ability to understand data, the math behind building models to make good predictions, like what will the user buy, and or, as we'll see later on, predicting audio waves, digital audio waves, audio for generating a song, generative AI, which is all just going to be an extension, as we'll talk about, of prediction. It requires you to understand the math and the data science behind that, and to understand the computers to make sure it's fast and cheap and doesn't pay NVIDIA a ton of money. That's an ML engineer. Can you do that in a coding bootcamp? As I say, we've had grads who've gone to it. We ran a data science machine learning research group for a bit, where some of our engineering grads went into, and then together the experience would get them an ML engineer role. So it's possible, but it's definitely a lot more than being a full stack software engineer. What I think you can do is become what I would describe as I'm not an ML engineer, but I'm a software engineer, not an ML engineer, but the but being I can work closely at integrating these new features of apps, particularly prediction. And we're talking here prediction of, as I say, user behavior, but also all the way through to predicting words, like when you write in ChatGPT and it generates words, a response. Integrating that is a mixture of data scientist, ML engineer, and software engineer who's ready and willing to work closely with the ML engineer to ensure that that prediction is live in the user's experience, in the product, meaning things like developing what's called a data pipeline. That's the flow of data informing the prediction, maybe generating a response in ChatGPT, giving the user the ability to, let's say, edit or respond to that prediction, ask another question, and then that being more data, more information that can make that prediction better next time. The software engineer is going to be building part of that. They're certainly going to be making sure the prediction is live on the internet, model deployment, a lot of which looks a lot like server development, back-end development, basically. So as long as, and that's what Codesmith has in its curriculum, we have all of that ML, ops, and GPT, these transformer-based neural network architecture integrated from pre-program into the program, and then even building products with it. So I think it's possible. I think it's, to me, it should not be just a kind of trivial bolt-on, like, hey, here's a bit of AI. It has to be built out end to end as part of the growth of you as an engineer. But if thought about in that way, it's certainly possible. But then I never really thought of a boot camp as being a place you went to go and learn. I went to a coding school, and I'm very grateful for it 10 plus years ago. And I think I'd give them credit while they proudly taught given technology, it was never really about that. It was really for them about instilling in you a degree of problem solving, a degree of capacities. They weren't as focused on what we're focused on, which is particularly, which I think has become more important, technical communication. Technical communication being, can I get my understanding of the code or the technology into your head? And that's hard and difficult for the person doing it and the person receiving. But that to me is bigger than the given tool. That being said, the mental models, the principles, the ability to learn anything, you still need to be able to have a decent map. And so that's why within the Codesmith program, we now think of it as being front end, back end, infrastructure. That's get your code on the computers, things like Docker, Kubernetes, make sure your program is live across many computers. Dev tools, that's the make you as the engineer as efficient as possible. That might be anything from, by the way, GitHub Copilot through to Dev and AI. These things haven't taken off yet. These are AI software engineering support tools. Haven't really taken off quite yet. Certainly GitHub Copilot has, and automated testing tools. And then the final bucket is ML adjacent engineering, or you might literally call it AI. So you've got front end, back end, infrastructure, dev tooling, and AI. So a full stack engineer now, I think undoubtedly will be, let's keep it very simple, front end, back end, and AI. And that's kind of wild. But that to me requires an augmentation of the curriculum, which has been really good fun to do. We have a team developing the AI curriculum led by the co-founder of Codesmith. We got very bloody lucky. He wrote the book on deep learning by Manning, reinforcement deep learning by Manning, that is a popular technique for building models that are extremely good at making predictions about things like responses to a user's question. And he helps co-develop the curriculum along with James Laff, who is a gifted curriculum developer and also front-end masters instructor later in the fall, which is cool. And so it does require evolving the curriculum, but it is also ultimately an extension of the same universal principles. One thing to add, I would just say, even more than before, if I'm saying that you need to have people in these leadership roles in tech because you're now dealing with healthcare software, making healthcare predictions, not just like operations around the edge of the healthcare system, but like core, same legal, same media. We were fearful of social media algorithms, Facebook algorithm. These are things which were black boxes. TikTok's algorithm is a question of geopolitical national security, at least, that would be the suggestion. You can bet if we're also making predictions about healthcare and law with algorithms that are essentially also models or algorithms, or at least ability to make prediction, that are black boxes, unknowns, you better have people running them who have lived being on the receiving end of technology. Otherwise, you end up with that same thing that happened in the mid 2010s, which is a realization that people building social media platforms had not been on the receiving end of technology and therefore didn't always bring the insight needed to think about what that would look like. You want to have, so what I love about coding boot camps, all of them, is they bring people who did not from day one wield technology from 12 years old. And whatever you think about Sam Altman running OpenAI, I think it's fair to say that he was wielding technology from 12 years old. And you need some people running this stuff for whom they had it wielded on them. Now we'll be able to wield it. And I think given how hard it is to change direction, and in a way that accelerates you past 18 years old in the US, you bet programs that give you that path past 18 years old to become a tech figure, you bet they become even more important when the things being built matter as much as they do, because it's going to be policy, it's going to be healthcare, it's going to be financial recommendations to individuals. It's going to be legal advice. You better have people running those who are not going to make the same social media algorithm 2015 mistakes that lead to maybe desperately problematic consequences.
That's such a good point. I love that. And so I also, when we're thinking about software engineers embracing AI in 2024, I mean, so much has changed even in a year. What is that actually looking like? Are there, like you mentioned, GitHub Copilot, that's really rising up there, but are there certain tools that in 2024 are the ones all software engineers should know and maybe be using? Or is it more of like a mindset shift and just thinking in more of an analytical way?
Oh, wow. Well, yeah, great questions. So I talk about this quite a lot in one of my talks, and we think there's 5 things that make a great software engineer: problem solving, technical communication, and that we see them as being like the very core. And it sounds very generic. Oh, communication, problem solving. Actually, to do it really well, there's a lot of frustration becoming a good problem solver, a lot of suffering, so to speak, not unduly, but yeah. Those 2 don't really change. Then there's what we call engineering approach. These are the mental models you might have, principles of how to think about things like code running. It does this, then it does this, then it does this. Or I don't know, other principles might be, I don't know, mental models like actually what you see on the screen, when you see the words on a screen, or let's say the number of likes on a tweet on the screen. For my whole life, I thought if it says 7 likes next to the heart for number of likes, of course, I don't even get that many. So let's say 1. It's really tragic, actually. Or the X, whatever it's called. You know, the 1 heart, like the 2, maybe 2 likes, maybe not 7, but maybe not even 1, maybe 2. I thought that number on the screen was the stored like data, was like the truth. Like if you added 1 to it, like heart, that the screen changing to 3. Now, under the hood in the computer, there must be stored, maybe it's obvious to you, but it wasn't to me, there must be stored the number 2 that can then have 1 added to it. And then you have to redisplay that as pixels. The 2 you see on the screen is just pixels. When you add 1 to it, you can't add 1 to pixels because they're just a shape on the screen. It's like it could be a triangle. It's got to have a number in the computer, in memory, in store, in JavaScript, for example. And then you add 1 to that. We know how to do that. 2 plus 1 is 3 in the computer. And then that gets displayed as pixels, the shape of a 3 by a rendering engine. Okay, like renders it, displays stuff. So like those are principles, those are mental models. That's your engineering approach. That has a few upgrades to add to it, because when it comes to machine learning AI, there are mental models that are quite different to the ones that are pure engineering. They're ones particularly about what is prediction, what is uncertainty. So this helps us understand why do LLMs predict words that don't make sense sometimes, or maybe make some sense based on prior data, prior word combinations. And this starts to give you mental models about things like embeddings. What are those? What does it mean to say what does it mean to say attention mechanism? A big part of transformed architecture. What does that mean? So those are engineering principles, which I'd expand a bit now to say engineering and AI principles. So there's a bit, that's where you said, are there particular tools? Well, there's actually step 1 is expand your mental models. And we've always tried to Codesmith, and you can, do this elsewhere, but you've always tried to have like pre-program, give people the mental models of programming before they even get in. We have all these workshops on hard parts of programming. Now we have them also on hard parts of LLMs and GPTs. That is to say, the mental models of what is happening when this large language model, LLM, makes predictions of the next words to respond to your question. What's happening? So there's that. It's the principles, and those are universal. In fact, I've got a talk in September, maybe, on Front End Masters on that with James, building those mental models of it. And the person who runs Front End Masters said to me, as long as you're doing a workshop on the principles of AI, okay. But if you're just doing the tools, specific tools, it's going to be changed in 6 months. it's going to have no lasting effect. Like that's my hard parts of JavaScript or programming. It's like 5 or 6 years old, version 2, and it's still their number 3 most played course because the principles, they last a long time. So first thing, establish for yourself as a software engineer embracing AI in 2024 an understanding of the principles under the hood. Okay, that's one. 2 is then experiment and build with the current tools. So there's 2, I guess, ways of thinking about 2 areas to think about. One is, let's say we have, I think probably the best example, because I don't really know how audio tracks work. So the best example is kind of a bit more boring. My favorite example of an AI tool is called Sora, SORA.com. Now it was .ai. And that allows you to write a prompt like on ChatGPT, and it will generate for you a song with those lyrics and all that. So you can write, like I wrote, like, make a reggaeton song about Codesmith. That's my favorite tool. Easier one for the explanation, I'd say, is one I really like as well, called Lex.page. To be honest, their features are largely, Apple just released its AI, Apple Intelligence. They're in there. Google Gemini in Google Docs has these features as well. But Lex.page is a text editor where you can write text, essays or whatever, and papers. And then you could say, for example, highlight a section and say, make this sound more, proofread this, make this sound better. Yeah, proofread this, come back sounding good. Maybe it's a bit scrappy right now, make it sound good. The data scientist's job was to build a model. What is a model? It's the ability, it's the code, because it is, code that's going to run on your input text, the messy text, and will generate the proofread version. Okay, so they did that by taking in lots and lots of historic data, maybe 100,000, maybe 1 million examples of, probably not that much, but like 100,000 examples of messy text, and then corresponding, maybe human generated, proofread, better text. Okay, the data scientist's job is to experiment with all the different creative approaches of analyzing the messy text, such that automatically in future you can put in some messy text and generate out some proofread text. So they'll be able to see, and actually they give weights, that's importance, like percentage importance, to different combinations of words that might indicate that's a bit scrappy, and generate a bit of a better sounding version, a more like proofread version. That's a data scientist's job. They're doing that potentially with a small number of input text. They experiment, they've got to understand the math, because the math that's doing the analysis, different models of different more or less complexity. They've got to understand statistics, understand how the prediction is, how sure is it, how confident are you in the prediction of the good text or the proofread text. Okay, data scientists. They're probably doing that on their own computer. It definitely ain't live on the internet that someone can use. That's where the ML engineer comes. The ML engineer comes in and says, hey, take that prediction, hopefully it's pretty good, but make sure it can work for lots of users and lots of cases, and do so as quickly, so it doesn't take forever when the user types in and says proofread, and it takes like 15 seconds. It can only take like 2 seconds. So the ML engineer says make it fast, and they want to make sure that making it fast doesn't make it bad. So to make it fast and not bad, they may need to understand both how the model's built, the math, the statistics, and computers. Like, how can you make that task not take too long on a computer? What's the nature of the task, such that you can maybe split that task up across lots of computers? That's the hardest, but most maybe fascinating job. And a lot of Codesmith grads will typically take a software engineering job for a year or 2, then pick up the ML data science side, or the data science side, sorry, and then take an ML engineer job. I mean, more and more typical. That is, and some of them, as I say, like the grad who just went to TikTok in May 2024, as an ML engineer, come straight out of the program, having done enough data science to combine up and get that ML engineer job. So then you have the software engineer who is embracing AI in 2024. And there's 2 ways they can do it. So first, they've got the mental models, the principles down, amazing. Now, what are the tools they can use? And why do they need those principles? To integrate that prediction, the proofread text, the input messy text, output proofread text, into an app. Because actually, there's a whole bunch of things that require them to understand how the predictions are working under the hood, for them to do their job well. So they built the like user interface. The user can type, press, generate, proofread text, and it gives back. They've got to design the API. That's like a URL, but they can send the not very tidy text the user wrote and get back the proofread text. They have to design that API. They might even help host, put on the internet, that predictive model that can take in the scrappy text and generate the proofread text. They might have to even deploy that, put it on the internet. They might have the ML engineers help, but they might not. They also might be passing to that model the user's text and shoot, it doesn't follow the right format for the model. The model needs it in, well, they don't even know because they need to understand how the model's working to be able to determine what format the text needs to be in. But they're really going to be a great contributor in the team. And then what comes back from the model is text that is proofread, but also in a weird format from the model. Again, they need to understand the model to integrate that proofread text for the user. But wait, dramatic. The user then has the ability to edit that proofread text. That's more data. And this is the data pipeline. That's going to allow our software engineer who's embracing AI in 2024 to take that edited text from the user, pass it back to the data scientist and say, hey, your model wasn't as good a predictor. Here's more data to make it better. That's all data pipeline development, pre-processing, post-processing. You've got as a data scientist, you've got to go as a software engineer, a regular software engineer, go, when do I want to snapshot the user's edits? Immediately or like after 5 minutes? And when does it start and end? You see how much like understanding what the model's going to need determines how you build that app. That's what a software engineer needs now. And embracing AI in this era means understanding that stuff. What are the tools you can use for that? Well, not all companies have a full data scientist, ML engineer. A lot of them are going to use like ChatGPT, APIs from OpenAI. And integrating those as a software engineer, the most popular tool is called LangChain. LangChain is, will it be forever? I don't know. If I were a software engineer in this era, I would be experimenting and playing with LangChain. Let's call it, it allows you to integrate those APIs from OpenAI or others in a way that is very software engineer oriented. That doesn't mean simplified at all. It just means that it's easy. It's the library LangChain is designed to work well within a software architecture. So that's a significant one. I would just encourage people right now when it comes to, so the other big bucket is regular engineering, but where you are using AI to speed you up. Without a doubt, while it makes mistakes all the time, ChatGPT remains most people's favorite go-to tool, Copilot as well from GitHub, but the ability to Socratic style almost chat with a pair programming partner as a software engineer with the help of ChatGPT remains just a phenomenal experience, and everyone still loves it. The agents, these are things like Devon AI that look amazing in Twitter video examples. In practice, they're mostly not going to be as effective within your complex environment. That means the place you're writing code in your technology system, that it still remains pretty hard to work out how to make use of them. They're going to get better. It's still going to require, of course, as always, all the complexity, or sitting down with a grad who works at Dropbox, works on their AI team as a software engineer, again, adjacent to ML stuff. And flipping heck, software engineering job it's very analytically interesting and challenging. He's loving. He's working directly with the CEO, Drew Houston. At least they meet every 3 to 6 months in a group of 3. So pretty cool. I'm kind of envious. But flipping heck, when I see their Slack messages during the day, software engineering, it's like it's not a bad grind. It's an incremental grind of can we work out how to make this feature get added without breaking all these things, and handling this stakeholder and handling these 7 people over here who want this feature, and then these ones over here saying, why can't we do that? And then this colleague saying, why can't we do that? And you'll say, I watch these messages. I'm like, flipping heck, software engineering ain't going anywhere. But But the tools you could use, as you say, ChatGPT remains the exemplar. Maybe Anthropic's Claude is excellent as well for code conversation and generation. LangChain being the go-to for actually integrating predictive features into your applications. And Copilot and other auto test generators for helping speed you up as a developer.
So, Will, you've talked about a few different Codesmith graduates who are now either working in AI or with AI. Are you noticing that Codesmith grads, when they're on that job hunt for that first dev role or tech role, are employers expecting them to know AI or machine learning at all?
It's a great question. Are they expecting? Hard to say. Is it an edge? For sure. So there's a kind of range of roles I would say I'm seeing. One is obviously ML engineer. As I say, machine learning engineer. That person has to understand the model, the math, the analytics, and the software engineering. We're going to see more and more of those grads, especially when you have people like, the data scientists from Meta, from Facebook, applying to the program to fill in the engineering piece so she can be an ML engineer. You bet you're going to see more and more of that, but that's not a huge area yet. You then have people who are getting proper like fusion roles. I'm talking they are a software engineer lawyer. No, that's right. Yeah, so that's software engineer lawyer. I just still can't get my head around it. And we're seeing more of those. We had another one, a Gen AI engineer last week who went to a $20 billion, I don't know, tech firm that kind of, I don't quite know what it did, but it's not maybe not one of the mainstream ones. Gen AI engineer. This is where you're right at the intersection of using potentially GPT-based prediction tools like LLMs and either customizing them with your software engineering knowledge or using them to generate, fine-tuning them to generate better predictions, again, with your engineering knowledge, turning them into products from the starting base of this is a LLM or some adjacent GPT tool that makes predictions, now build a product around it, extend it, fine tune it, understand its predictions, make it good. Like we're seeing, but I'd say at this point, up to at least 10% of people going into those sorts of roles. Some of those roles are, we got one who's just gone as a software senior. They're on like I'm not gonna, it's a 150, 160 kind of role. They're a consultant, reinforcement learning. We mentioned earlier that Alex I, co-founders, worked in with human feedback consultant. So they're in the mid 100s in a role that, as far as I can tell, and we've had quite a few grads go into this role, is something along the lines of ensuring that the code being generated by models is decent, follows for large organizations best practices, and is actually able to solve problems. That is to say, they're working on, and they may be leading others in ensuring the model, the prediction, the generation of code is good. Flip an egg. So that's a whole nother thing. That's like you're working with a AI model, a GPT, you're making predictions and you are assessing its output based on your expert knowledge as an engineer. Okay, that's another bucket. And then there's the bucket of which is what we're really mostly targeting for Codesmith grads, of every other software engineer who increasingly either's working one person removed from prediction, that is predicting words, predicting pixels, image generation, or let's call it generation, or maybe even doing it themselves. And that is when you start to see the curriculum additions we made, so that every person comes out full stack for 2024, front end, back end, AI, infrastructure, tooling. Actually, it's funny, infrastructure and tooling both have kind of a lot of AI heavy elements as well. So yes, 3 different buckets. 1, straight up ML engineer. 2, right there at the like feedback on AI predictions. Really at the very core, it's an AI model that you are extending because of your engineering / expert knowledge in either code or law or whatever. And then 3, every other engineer who's going to have to build with these tools and integrate these predictions. Yeah, so that's how I've seen it play out so far.
Yeah, and it sounds like to differentiate yourself as a new to the tech scene technologist, you should have some kind of understanding, some kind of grasp of what's happening out there in AI.
That's
Yeah.
why we've added this whole chunk to the curriculum, but I just don't think one wants to be thinking of it too much as just a bolt on. It has to, and that's what we really wanted to do, is recognize the full journey of understanding. Codesmith goes from get mental model of domain, programming, how it runs, LLMs, how they work, implementation details, what exact tools, that's from LangChain in LLMs or in AI, through to, I don't know, React in front end, through to Node in back end. Hopefully the tool change doesn't matter because you understood the principles first. Principles, tool implementation, build projects with it, then build tools for other people. That's this open source thing they do at Codesmith. Build tools for other developers to use the mainstream tools, like build a visualizer to let other developers better understand how their React code base is working. And then in the hiring program, learn how to talk to these topics, learn how to talk about the choices you make as an engineer in front end or whatever. To me, properly integrating, I'm probably kind of giving away the secret here, but like properly integrating AI into a curriculum is seeing it as that full journey. Mental models at the base, how do LLMs work, how do GPTs work under the hood, hard parts, pre-program, implementation, LangChain, sure, build projects with it, build open source tools that enable software engineers to use things like LangChain more readily. That's going to be really exciting. And then learn to speak to the topics in the hiring program, as you say, to have that edge in the job search. So yeah, definitely agree.
Well, I feel like that's a perfect place to wrap up this Q&A. Thanks so much, Will, for sharing all of your insights about this. And thank you everyone who will be watching this on YouTube. We're going to be posting a transcript of this video interview on the Course Report blog with contact information for Codesmith, just in case you're inspired to apply for any of their upcoming in-person or online cohorts, or check out any of those events that Will mentioned. And in the meantime, you can follow Course Report on Facebook, LinkedIn, and Twitter. And if you're a bootcamp alum, don't forget to post a review of your coding bootcamp experience on Course Report. Your review is a huge help to anyone who's thinking of getting into tech today.